In this video, we will be discussing about map of highest peak. You are given an integer matrix is water of size m cross n that represents a map of land and water cells. If is water of I, j is 0, then it is a land cell, and if it is 1, then it is a water cell. You must assign each cell a height in a way that follows these rules. The height of each cell must be non-negative. If the cell is a water cell, its height must be 0. Any two adjacent cells must have an absolute height different of at most 1. Find an assignment of heights such that the maximum height in the matrix is maximized. Return an integer matrix height of size m cross n where height of I, j is a cell's height. If there are multiple solutions, return any of them. So what they are saying is that in the input, we are given an integer matrix is water of size m cross n. Now this is having only one values, 0 and 1, right? 0 denotes a land and 1 denotes water, right? So now what we need to do is that we need to assign a height to each of the cells, and that height has some rules, right? So what they are saying is that the height that we are assigning, that should be non-negative, meaning it can be either 0 or positive, right? Then the next thing is that wherever we have a water cell, its height will always be 0. And the third thing is that the difference between the height of any two adjacent cells should be at most 1, right? Difference has to be at most 1. So basically by the adjacent cell, they means if this is the cell, then the cells adjacent to it will be the top, left, right, and bottom, right? So the difference in the height of a cell with its adjacent cell should be at most 1. Basically, the absolute height difference between any two adjacent cells should be at most 1, right? So see, we will have to create a new matrix which is going to be of the same size, right? Now here, as it is said that all the water cells will have the height as 0. Water cells are represented by 1. So here we have a 1 and here we have a 1. So this height will always be 0. And the other cell's height, we need to decide what should we give, right? Now, our ultimate goal is to maximize the maximum height that we have in this matrix, right? So see, basically, if you see, this is mandatory that the water cells will have a height of 0, right? And it is said that the difference in the height of any two adjacent cells is at most 1. So if I consider this cell, then the cells adjacent to this is this particular cell and this particular cell, right? So one option is that I can give the height as 0 over here, right? So the difference will be at most 1 and the height is also 0 or positive, right? And then for this cell also I can give 0, 0, 0 over here, and then everywhere I can give a 0, right? This is one of the possible solutions. But here we are not maximizing the maximum height, right? In this particular case, the maximum height in the matrix will be 0, but we can maximize it further, right? So see, if I have a 0 over here, I can put a 1, right? If I put a 1, then the absolute difference will be 1, right? Which is at most 1. And then here also I can put a 1. But can I put a 2? No, because then the difference between these two heights will not be at most 1, right? So basically, whichever cell is adjacent to it, there I am having two choices for the height, right? One is 0 and one is 1. And same over here as well, right? Since now we need to maximize the maximum height, so we will try to greedily choose 1, right? We will try to greedily choose 1 always. So basically, since this will always remain 0, so what we understand that if we are greedily choosing 1, then whichever are the cells adjacent to these cells, they will always have a height of 1, right? So these will have a height of 1 and these will have a height of 1, right? Now if you see at this particular cell, so this is adjacent to this, this and this. Here we have not assigned any height yet. So according to these, what value can we put here? Either it can be 1 or it can be 2, right? None, or it can be 0 as well, but 0 we won't put, right? So since we want to maximize, we will put 2 over here. And then for this cell, the adjacent cells is 1 and 2. So we can either put a 1 over here or we can put a 2 over here, right? So we will put a 2. So now the maximum height in the matrix is 2, right? Earlier it was a 0, but now it is 2. And this is the maximum height that we can achieve for this matrix, right? So this is what we need to return as our answer, right? So now how are we going to solve this? So see, we know that all of these cells are fixed. They will always have a height of 0. The cells adjacent to it will have a height of 1. And then the cells which are adjacent to these particular cells, they can have a height of 2. Then next neighboring cells can have a height of 3 and so on. Right? So does this give you a hint of applying BFS over here? Right? In BFS, what do? We have a particular node. We traverse or we check all of its neighbor nodes, right? And then one by one we check the neighbor nodes of the neighbor nodes, right? Basically, it's progressive, right? We keep on checking the neighboring cells. So same here also is happening. But the only different thing over here is that in the BFS, what do? We take a queue, right? We take a queue and in that we put a root node, right? Basically the starting node or the starting cell. But here in our matrix, we can have multiple starting points. This is also one of the starting point and this is also one of the starting point. Both of their neighbors should get a height of 1, right? So when we are applying BFS over here, we are not having a single start node. Instead, we are having multiple start nodes, right? So this is known as a multi-source BFS. Okay, so what we can do is, firstly, let me write the indices. So 0, 1, 2 and then this 0, 1, 2, right? Now, these are the starting points for us. So we will push them into the queue, right? I'll just write it here. So in the queue, initially we will push the row and column of that particular cell. So 0, comma 2 and 1, comma 0. This will be present in our queue initially, right? And then same process we will follow that while our queue is not empty, we will take the size of the queue, right? So right now the size of the queue is 2. So a for loop will run 2 times. In first iteration, we will take this out. In the next iteration, we will take this out, right? So first we are taking 0, comma 2 out, right? So now here you have 0, comma 2. Now you will check all its adjacent cells. So adjacent cells will be these, right? These two are not valid. So we will consider only these two, right? So initially you can take a variable height, right? And you can initialize its value to 1. So now when you have checked that its neighbors are these two, you can give the height as 1 to these two, right? So they will have a height of 1 and then these particular cells will now be pushed into the queue, right? For further iterations. And then we'll take this out and then we will take 1, 1 height for these also. The only thing that you must remember is that when I have pushed a particular cell into my queue, I shouldn't put it again, right? I shouldn't assign height to that particular cell again. So we will also have to mark whether a particular cell has been visited or not, right? So for that, either you can create a different matrix of the same size, right? Or you can utilize your resultant matrix only, right? So see, initially what you can do is you can keep all the values as -1, right? All the values as -1 and then wherever you have a water cell, there you can keep the value as 0, right? So since initially here all the values are positive, we are only having 0 and 1. So here -1 is denoting that this particular cell has not been visited yet or we have not assigned any height to this particular cell, right? So whenever you are inserting into the queue, basically whenever you are considering a particular cell, first you should check that it should be -1. If it is not -1, then we won't consider it, right? So now when we will take this 0, 2 out, so its adjacent cells will be these two. So we will give the height as 1, right? And then we will push them into the queue. So we will put 0, 1 and then 1, 2. Then we will take this out 1, 0. Its adjacent cells are these three. So we will give a height of 1 to these three. So 1, 1, 1 and then we'll push this also into the queue. So 0, 0, 1, 1 and then 2, 0, right? So now we are done with our for loop which was running 2 times for these cells, right? So now we will increase our height by 1 because now we are considering the neighbors. So as we are moving to the next layer, we will give the height as +1, right? So now you will see we will take this 0, 1 out. For 0, 1, this is the cell. So its adjacent cells are already visited. So now we'll move on to the next, which is 1, 2. So 1, 2 is this one. Its adjacent cell is this and this. This has not been assigned any height yet. So we will give it a height of 2, right? So here we will give a height of 2 and we will push 2, 2 into the queue, right? Then here we have 0, 0. So 0, 0, all the adjacent cells are already visited. Then next is 1, 1. So this is the one, its adjacent cell is this. This is having a height as -1. So here we need to assign a height of 2, right? So this will change to 2, and then we will put 2 comma 1 inside our queue, right? And then we have this 2 comma 0. So 2 comma 0 is this one. Already we have been visited the adjacent cells, right? So now we are done with this. Next, we will increment our height by 3. We will move on to the next level, but here you will see all the adjacent cells are already visited and our BFS will be completed, and this will be our resultant height matrix which we need to return as our answer, right? So this is what we need to do. Now let's quickly look at the code. So first of all, let's create the directions vector, right? The 4 directions, basically the 4 adjacent cells, right? So it will be 0 comma 1, 0 comma -1, then 1 comma 0, and then -1 comma 0, right? And then let's take the size of the matrix. So M will be is water dot size, and N will be is water of 0 dot size, right? And then let's create the resultant matrix, so which will be a vector int. Let's name it res, and its size will be m cross n. So m vector int n comma, initially we will keep all the values as -1, right? And then we also need a queue in which we will store a pair, right? Row comma column. So pair int comma int, let's name it queue. Now what we want is that wherever we have a water cell, we will give a height of 0, right? So we will run a for loop of I starting from 0 going till m and I plus plus, and then for int j equals to 0, j less than n, and then j plus plus, right? Now inside this we will check that if in is a water vector at the index I comma j, if this is equals to 1, right? Then in that particular case, we will first of all push it into the queue. So it will be I comma j, right? Because these are the starting cells for us. And in the resultant matrix at the index I comma j, we will give the height as 0, right? Now once we are done with this, we will start with our BFS. For BFS, we also need height, which will initially be 1, right? Then we will run a while loop that while our queue is not empty, we will take the size of the queue. So in size equals to queue dot size, and then we will run a for loop of I starting from 0, I less than size, and then I plus plus, right? And then inside this we will take the front of the queue. So this will give us the row and the column of the current cell. So this will be queue dot front, and then we will pop it. So queue dot pop, right? Now we need to check all its 4 adjacent cells, right? So for auto direction in directions, right? So the new row will be whatever is the row, current row plus direction of 0, and the new column will be column plus direction of 1, right? Now, we need to check whether this particular cell is valid or not, nr comma nc, right? So, if nr is greater than equals to 0 and nr is less than m and nc is greater than equals to 0 and nc is less than n, and in the resultant matrix, nr comma nc is equals to -1. That means this is being visited for the first time. Only then we will give it height and push it into the queue, right? So we will give it height in the resultant matrix at the index nr comma nc. We will give the height as height, right? And then we will push it into the queue. So nr comma nc, right? And then once we are done with this particular layer, we will increase our height by 1, right? And at the end, we can simply return the result. So now let's try to run this. So here if you see, we are running a for loop m cross n times, and then here our while loop is doing BFS, and in this we are pushing each cell exactly once into the queue. So this will also take m cross n time, right? So the time complexity will be order of m cross n, and space complexity will also be order of m cross n, because we have taken this queue, right? Which in worst case will store all the cells, right? So let's submit this now. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.